Hello and welcome to mathgirl.org. I'm Math Girl, and today our lesson is on multiplying and dividing radicals. Let's begin. Before we start, let's note that there's a big idea when you're multiplying radicals. You see, the outside numbers get multiplied together, and the inside numbers, the ones under the radical sign, they get multiplied together also. So what do you think happens when you have 5 square root of 3 multiplied by 4 square root of 2? Remember our big idea. The outsides get multiplied together and the insides get multiplied together. So what you should have gotten is 5 times 4 multiplied by square root of 3 times 2. Well, we call this a radical. 5 times 4 cleans up nicely to 20 square root of 3 times 2, which is just 6. And we always try to simplify our radicals, but I think this one's pretty clear. Let's try a different one. Let's remember our big idea. So this is equivalent to saying radical 3 times 12 or radical 36, which cleans up nicely to its perfect square factor of 6. What about radical 3 times radical 8 or square root of 3 times the square root of 8, whichever you prefer? You guessed it. It's 3 times 8 under a radical sign, which is just the square root of 24. And as your teacher has told you, you're looking for your very good perfect square factors of any number. You see, I know that 24 can be broken down to the square root of 4 times the square root of 6. So our final answer here is 2 radical 6. Let's try something a little more challenging. See, this one can be thought of in two ways. Perhaps you've noticed that the square root of 9 is 3, and we are multiplying it by 4 times the square root of 25, which is 5. So we're basically just doing 3 multiplied by 4 multiplied by 5. Or 60. But what if you didn't see that? Let's try it a different way. Remember that the insides multiply and the outsides multiply. So my outside numbers are 4 and, well, that invisible 1. So we get 4 radical. The inside numbers are 25 and 9. That multiplies to 225. And 225 is a perfect square. So this is equivalent to 4 times 15, which is 60. Isn't math fantabulous? Let's try a different one. Remember our big idea. The 6 and the 7 multiply together to give me 42, and the 8 and the 2 multiply together to give me square root of 16, which is a perfect square. This is equivalent to 42 times 4, or 168. I love it when these work out. Let's try a little distributing. This acts as if it was any other integer distribution. I'm going to multiply the square root of 5 to both parts of my parentheses. When I take the square root of 5 and multiply it by the first square root of 5, I get the square root of 25. When I take the square root of 25 and square root of 5, multiply it by 2, I get 2 radical 5. Remember, insides with insides and outsides with outsides. This 2 is a purple number. It's an integer. It is outside of a radical that I can't see. There's a plus sign in between here. Don't forget that. And our radical 25 cleans up to 5 plus 2 radical 5. Now, don't go thinking that there's another step to this. This is the answer. You see, this is the furthest I can get. And I'm sure that addition of radicals is coming soon to a math class near you. What about dividing? You guessed it. The same way we can simplify radicals using multiplication, I can simplify radicals using division. Whenever you see a fraction in the form of a over b, that can be simplified to the square root of a over the square root of b. Let's see some examples. So when I have big radical 49 over 25, That's equivalent to saying radical 49 over radical 25, which cleans up really nicely to 7 over 5. Let's try that again. What if I have big radical 5 over 4? Okay, that's little radical 5 over little radical 4. And technically, I can keep going. This is radical 5 over square root of 2. Another great answer. This is the first time we run into a slight problem. You see, when I apply the division property and I break this down to radical 9 over radical 5, our numerator cleans up pretty great, but our denominator is still stuck as a icky irrational number. Now let's think about this. You're taking a really pretty integer and dividing it by an irrational number. Dividing by something irrational, well, that's just crazy. We'll do something called rationalizing our denominator, where we multiply the entire fraction by a value of 1, except the value of 1 that we are selecting is the same as the denominator repeated. In this case, I'll have a 3 multiplied by radical 5. Our numerator will be 3 radical 5. And on the bottom, our denominator would be radical 5 times radical 5, which is radical 25, or just the number 5. This is our final answer in this problem. One more. Let's keep going with this one and break it down to radical 5 over radical 3. Again, an irrational number in our denominator. This is not good. The math police will come, arrest us, take away our calculators. We can't have that. We will rationalize this denominator by multiplying top and bottom by a version of 1. Remember, we'll use our denominator as a clue as to what version of 1. Since our denominator is radical 3, I'll multiply top and bottom by radical 3. Our numerator is radical 5 times radical 3. Both of these are inside the radical sign, so that'll be radical 15. And the denominator is radical 3 times radical 3, or just radical 9. Works out nicely. We get radical 15 over 3. It worked. We did it. Yay! Thanks so much for listening in on our lesson on rationalizing denominators, multiplying and dividing radicals. Thanks, and I will see you soon.